Hi everyone, welcome to FHIR Basics Session 5. This is the final session of the FHIR Basics series. And today we will be talking about some of the implementation considerations that implementers should take while doing the implementation. So while embarking on the implementation. My name is Kumar Satyam, and below are the links to get in touch with me, my LinkedIn account and my Twitter handle. All right. So before we get started, I would like to acknowledge the contributors to this slide. So I have borrowed the content from the various members of the FHIR community. So these are the names, some of the names. And then today's agenda. We are going to do a quick recap of basics of FHIR that we have covered in last 4 sessions. We will then go on to today's agenda, that is implementers consideration, implementing servers, and next steps, right? So before we get started, a word about FHIR India community. It's an open community for FHIR and interoperability enthusiasts. This training is being run by the FHIR India community itself. It's an open community. There is a discussion forum, a LinkedIn group, and a GitHub account also. So now GitHub, you can find a lot of resources with regards to various projects that we had undertaken in the past. And you will also find some of the profiles that were created as part of the Connectathon last year. All right, so one important announcement that I want to make is from today, the discussion forum, the FHIR India Zulip chat, is going to be invitation only. So the open invitation or open discussion forum is going to close. Now, in order to be a member of the discussion forum, you'll have to have an invite. Without invite, you cannot join the discussion forum. So the settings will kick in today in the night. So if you are not yet on the discussion forum, please be on that. And the link is here, the FHIRindia@zulipchat.com. All right. This is some of the contributions that the community has made so far. And I'll just pause a minute so that you can read it. And then moving next, housekeeping announcements. I think we don't have to repeat anything. So please be on mute when the session is going on. If you have any questions, please put it on the chat. A chat is monitored by our volunteers. And if there is a relevant question or relevant interjection to be made, Avanti, who is monitoring the chat, will notify me. And further, all the discussions will continue on the discussion forum. The materials and the recordings will be shared on the discussion forum. All right, so with this, we get on to the recap. Recap will be a very quick, very fast recap of the important concepts that we learned over the last 4 sessions, or say like 6 to 8 hours. And it will give you a brief understanding of the important concepts of FHIR. What is FHIR? The first thing. So FHIR is a standard from HL7 International. The current release of the FHIR standard is release 4. The full form of FHIR is FHIR Fast Healthcare Interoperability Resources. And the important thing to note is its status, current official status of the standard is mixed normative. Right? Mixed normative means that certain part of the standard are stable and normative, and certain parts are still in the draft stage. So that's what a mixed normative is. Okay. So the fast healthcare interoperability resources, that is FHIR, is standard for healthcare data exchange, and the healthcare data in the FHIR standard spec is represented as resources. So when we talk about FHIR data, we are generally talking about resources. Okay. And FHIR is based on the RESTful paradigm, or FHIR is influenced by the RESTful architecture style. So most of the FHIR artifacts or FHIR terminologies will resemble RESTful. And we'll see about this as we go along. So keep in mind, FHIR is an HL7 standard and it follows RESTful paradigm. And resources are the data which get exchanged in FHIR. Resources have an uniform address on the server, which can be accessed by the clients. So every resource has an address on the server, and that resource can be accessed using the address by the client. Okay, and how would the clients access the resources? They will access the resources using HTTP methods. What are the HTTP methods that FHIR clients can use? They can use post, put, delete. What else is remaining? And get. Yeah. So these 4 methods. And also, apart from that, FHIR also has certain extensions or operations that can be has been defined, which extend the capability beyond the basic CRUD operations of HTTP verbs. Also, FHIR supports formats like XML and JSON, which are the primarily data exchange formats. Apart from that, Turtle RDF and NDJSON are also supported formats, but in specific use cases. Mostly, I have seen XML and JSON being used widely. NDJSON, or the new line delimited JSON, is used in bulk FHIR spec. And RDF, I have not seen much use in terms of FHIR specs. And so that's the RESTful paradigm for FHIR. So just remember one more thing. Since it is RESTful paradigm, so implicitly what happens is FHIR divides the world into clients and the servers. So whenever you're talking about a FHIR system, it's either a client or it's a server, right? So just keep in mind that. So FHIR is a client server a type of an architecture. Either there is a client or there is a server, right? So keep that in mind, okay? Now, as we said, like FHIR servers, right? So FHIR is a client or a server, right? So the FHIR servers, who are the core of the FHIR spec, or basically what happens is the FHIR servers are the ones who have the data, who are providing operations on the data, right? And the clients are actually sending instructions to the server to do certain things, just like a typical web exchange, right? So the FHIR-based services or the FHIR servers support 3 types or 3 levels of services. The system level services, which are at the core system level, which could be like, what is the system's capability, right? That, and then type level, so resources, right? So resources have types, right? So the data has type, like the type is patient type or practitioner type or observation type, right? So there are certain operations that can be done at a type level, right? For example, create a resource of type patient, or create a resource of type observation. So that's a type operation, right? And then once the resource is created, it gets an identity and an address on the server, right? Using that address, you can actually do instance level operations, right? For example, get me the resource with ID 1, which is patient. So get me the patient resource having ID 1. So you have a get request, right? Similarly, you can do an update because now you have the resource address, full address, so you know where the resource is located, right? And what is the type of the resource. Then you can actually do get, update, delete, or look at the history. So broadly, there are 3 levels at which the FHIR servers provide different services: system level, type level, and instance level. Okay. Okay. So we talked about resources and we say that resources are data, right? So let's define a little bit more or see a little bit more what are resources. Okay. So resources are small, logically discrete units of exchange. So you can think of resources as the smallest unit of exchange, meaningful units of exchange in FHIR, right? So resources are the things that you exchange. That is the smallest granular pieces that you can think of, right? Resources have a behavior and a meaning. So when you say patient, a patient is a resource. It has a defined behavior, right? So patient has a behavior like saying that it will contain patient demographics, right? And the meaning, you understand patient, what will the meaning of that resource be, right? And what kind of operations can be supported, right? So patients can support a create update of a patient, those kind of things. And we talked about the known identity. Every resource has an identity on the server or an address on the server. And we already discussed that it's the smallest unit of transaction. A bit formal from the FHIR spec itself. You can read about it. I'll just pause for a minute. Okay. So moving on. So, but what good are resources? We said that resources is a resource, practitioner is a resource. So these are resources, but what do the resources do, right? And why do we care about resources? So the answer to it is resources, a logical and informed use of resources actually helps us solve various use cases in healthcare, right? So think of resources as Lego blocks, right? And so that's the right hand side, the Lego blocks. And then what's possible with the Lego blocks, right? So you can actually orchestrate an ambulance service. You can orchestrate an OPD visit. You can orchestrate a lab result and lab order and a lab result kind of scenario, right? So with resources, using resources, right resources, you can orchestrate different flows in healthcare, right? So that's why if you have to think about resources, you can broadly think of resources as Lego blocks, the smallest units. If you have seen the Lego blocks, they are the smallest unit. But using multiple Lego blocks, you can build a lot of wide variety of things. So that's how you can think of resources also. So resources are small units. Combining resources, you can get a lot of workflows done in healthcare. Okay. So we looked at resources. We talked about resources and what resources can be done, right? So for example, and we talked about a scenario, like we talked about a scenario in session 3, I guess, where we talked about a lab order and a lab report exchange. A patient goes to a doctor orders a lab result to be done. The lab results come back, and then there is a prescription happening. So these are all workflows happening, and in each of the workflows, one or more resources were used. Now the question is, what do the resources contain, right? So the resources contain uh, logical information about a particular entity, right? So for example, you have in front of you a patient resource. A patient resource, if you see, has the standard data. If you see here, it has MRN, name, gender, date of birth, provider, everything here, right? Also, it has a metadata like about the resource. What is this resource? We talked about the identity of the resource. All those things go into the metadata and the resource identity. Then resources also have a narrative section. What narrative section does is, whatever is there in the structured content of the resource, actually that is rendered and presented in an XHTML format. So here the another like core principle of FHIR is human readability, right? So it is possible, or it may be possible that you the machine may misread something, or it's important to understand that the operation that was done was right or wrong, right? A human needs to verify whether the content of the resource and the outcome is the same, right? So in that case, there should be a way for human to look at the resource and figure out like what is the content of the resource, right? And that's why there is human readability aspect in a resource. So any resource you take, right, there will be structured data which will be like which will be mostly machine processable, and then there will be a narrative section which will be an HTML block which can be rendered on any web browser, right, so that a human can read it easily, right? And that way somebody can identify whether the content of the resource is matching the expectation or not, right? And other thing to note is there are extensions in a resource. So what happens is, and this is again something that is the basic philosophy of FHIR, that FHIR does not model the entire world or model the entire healthcare scenario. It does not do that. What it does, it just models the most commonly used scenarios, right? And because of that, what happens is specifics get missed out, right? So in that case, everyone or the use cases, just give me 1 minute. In that case, the use cases would require certain specific attributes to be added, right? And those additions are possible through extensions. So you can think of extensions, and if you have worked on HL7 V2, you can think of extensions as Z segments. Yeah, Z segments are the right ones, but in FHIR, the difference is the extensions are actually regulated, and there is a standardized way of defining extensions. So that way, even if an extension is defined and which is expected, it can be easily understood by the receiver. Okay, so that's why. So basically, a resource contains structured data, a narrative section, a section which is the metadata about the resource, and also certain extensions if required. So that's the high-level content or the structure of a resource. For more example or for more details, you can just look at this example, and the details are provided at hl7.org FHIR/summary.html, and this is the path. All right, you can go and read more about it.
Then we have a request regarding, can you please explain the human readability part again?
Yeah, so the human readability part is, so first the purpose of human readability is to be able to inspect, a human should be able to inspect the content of the resource, right? So that's one, and this could be done because just to verify whether the content in the resource is right or not, or for various QC and other purposes or emergency purposes, right? So the narrative or the human readability section of a resource actually is an XHTML representation of key structured elements of the resource. So for example, in the example here, if you see the text, this color, right, the reddish color, right, the text, right, the text has the human readable item, right? It's an HTML thing, and what it says is Henry 11 the 7th, MRN is this, male, and 24th September 1932. So this is what it is there in the text, right? And if you see, the same thing is represented in structured content. So somebody who is looking at this resource and opens this resource on a web browser, right, they should be able to, even if there is nothing, no FHIR specific or no FHIR specialized tool or no FHIR server or FHIR client, if they just open the resource, they should be able to read this, or this will be rendered on their screen, right? And since it is a patient resource, they will understand that it's talking about patient whose name is this, MRN is this, gender male, and like this, right? So that's the piece about human readability. So if there is a specific question about human readability, I can answer that.
No, I think Ayaz, that is clear.
Satyam, one more question related to this. So like when it is in XML format, I think it can be rendered in a human readable format. But what if the resource is in JSON format? Can you see it on web browser? Simple name, I mean, the information that.
I think that's a good question. I have not tried it, but you can put in HTML there as well. We can experiment that. So that's a good one. I did not experiment that, but I think we should be able to see. I may be wrong, but a good question. If somebody can verify it quickly, just go to the FHIR patient resource and go to the examples. In the example, you'll get XML and HTML both, XML and JSON both. Just try to open both on the browser and see what happens. And let me know the answer. Yeah, that's a good question.
Okay, we have one more question. Which format is good compared to one another, XML or JSON?
That we will talk in the implementer section. We'll go there. So today's topic is that only, right? So we'll take that question later. Okay. Okay, moving on. All right. So this is the last section on the recap, and this is about the FHIR manifesto. So the principles of FHIR are based on these manifesto items. The first one is a focus on implementers. So the FHIR standard itself is focused on implementation, right? So a standard is good only if it's implemented, right? If there are more and more implementations of that particular standard, right? So the FHIR developers understood that. And therefore, the focus of FHIR is actually to provide more support to the implementers so that there is more and more FHIR implementation around the world. And we'll see that. The second one, we talked about the target common scenarios. What it means is, so a bit of history about HL7 v3. So what happened was HL7 version 2, right? And whoever has worked on HL7 version 2, and even if you have not worked on HL7 version 2, so HL7 version 2 was a messaging standard, or is a messaging standard, which is used by, you can say, 95 or 99% of the healthcare systems in the world. And it's like a pipe separated text-based format of exchanging healthcare information. Okay. Now the problem with that was it's a very, very flexible and a loose standard, right? And there are a lot of ways by which people can actually make it incompatible, right? They can just adapt it for their own way, right? So now what happened is, with these problems, HL7 embarked on a mission to make the standard more structured. And they embarked on a journey of creating HL7 version 3, okay? And version 3, in all respect, was a very fantastic standard. It tried to model everything possible in the healthcare information exchange. But the problem happened was, like, it became very complex because they tried to model each and every scenario that is possible, right? And it was an XML-based format. So it became very, very tough for people to implement. And therefore, what happened was, slowly, its usage declined. And it was understood that HL7 v3 will not succeed. Some portions of it have succeeded, like the CDA or the remarchitecture, but for entire part of it, it was not a quite success, right? So based on that, with the learnings of that, HL7 Fresh Look Task Force was formed. And the goal of the task force was, and this was done in around 2011, that if a healthcare information exchange is to be looked at today, what will happen, right? And from that, the genesis of FHIR came up, right? And that's where they discovered that, okay, maybe the old HL7 world was within the hospital. It was more about server to server communication. But in the next generation, the healthcare will be moving out of hospitals, and it will be more decentralized, more federated. So there will be web-based exchange of healthcare information, right? And then they also realized that modeling everything in the healthcare IT space is not possible. So they took a conscious effort to actually pivot and say that we will only support in the base the scenarios which are actually very, very widely used. So actually the philosophy is 80-20 rule. Include in the base standard something only if it is used in 80% of the scenarios, right? So that's how the rule goes. So that's the target the support for common scenarios. And that has actually led to the wide success of FHIR. It has actually made the standard very simple, but also there are things like we are seeing, like there are a lot of profiles coming up. There are a lot of implementation guides coming up. But those are the secondary aspects. But that's the point number 2, support for common scenarios. Leverage cross-industry web technologies, as we have seen, right? So it supports XML, JSON, it supports HTTP, right? So no rediscovery. Just use the latest the web technologies. That's how the standard advocates or uses, right? Human readability as the base level of interoperability we saw, right? So narrative is part of each and every resource, right? So that's what the human readability, and this is the good part. You do documents in FHIR. Okay. So with that, we get on to the next section, which is on the implementers. And that's the focus of today's session. So we'll pause for, say, 5 minutes. If there are any questions regarding the recap or any specific thing you wanted to talk about FHIR, this is the time. We can talk for 5 minutes, 5 or 10 minutes.
Okay, there was a question from Tanveer.
Okay.
Is it possible to have HTML in JSON? So I said we need to check that, but if you can take it right now.
That's what,
actually, I actually answered the question about that. So with the link below, there seems to be a possibility that you can have HTML embedded in that.
Yes, it's an HTML. You can embed it. I just wanted to make sure that you can actually do it and see.
Oh no, not yet from.
Okay, but not a worry. If we time permits, we will just take a look at it.
Yeah, then there was a question from Ayaz. What are the main issues with HL7 V2? So I pinged him the link regarding the comparisons with FHIR and V2. So if anything specific,
no, I think that's comparison is good.
Yeah, right. Yeah. Okay. Another is FHIR supports only common scenarios, means does not allow to full implementation with FHIR. Ashok, can you elaborate a bit on that?
Yeah, sorry.
Please, yeah.
I understood like, you mentioned like there is a supporting only common scenarios. I'm not clear what exactly common scenarios means. See, there is a something, if you go for full implementation, maybe you need to support all kind of scenarios, correct? So that is clear.
Yeah, I got the question. So support common scenarios means that the base specification of the FHIR, means the specification that is published at hl7.org/FHIR, right? The base spec of FHIR something will only get into the base spec if it is used in most of the scenarios across the world, right? So what it means is if some corner cases are there or some edge cases are there, right? Or something very specific to one particular area of practice is there, right? For example, those may not make into the base spec, okay? Now, it does not mean that FHIR does not support them. So that's why, so first thing is support common scenarios. And the second piece is extensibility, right? We talked about. Since FHIR spec supports only the base specs provisions for common scenarios, right? It also provisions for extensibility, right? So that specific implementations can actually adapt the standard, okay, and extend if needed to support their use cases, right? And the most common example that I quote is, for example, US race, right? So for example, in US, race is required for healthcare transactions, right? So in the patient demographics, you need to have race, okay? But the FHIR team found that race is not a requirement for most of the other countries, right? So what happened was race as an element, right, attribute, was dropped from the FHIR spec. So the patient, if you see the patient resource, the base patient resource at hl7.org/FHIR/patient.html, you will not see race as an attribute. But now US needs that, right? So what they did was they added an extension, US core race, right? And then now all the US implementations actually use that US core race extension to meet their purpose, right? So now this extensions, the thing is, like, the question would be, if you have anyone is doing the extensions, then there will be a lot of extensions. And then people will be lost in what extensions, and everyone will go with their custom extension, right? So for that, there are a couple of things. First, there is an extension registry. You should be checking the extension registry before deciding or to create your own extension. Second, extensions have a standard structure. You have to follow them. And that way, even if you have an extension, the receiver would be easily understanding it, right? And then the concept of profiling that we talked in the last session was that generally what happens is you take the base spec, and then typically what we have seen is there is a country specific customization that happens on top of the base spec, so that there becomes a company specific FHIR specification, right? So US has US core, right, which is US specific FHIR specification. So they don't typically use the base FHIR, but they use the US core, and all their implementations might be happening on US core. I'm not very sure, but I think US core is what is the mandated one. Similarly, other countries, Netherlands might have their own. So that's how there is a country level customization that happens. And then within the country, if there is certain specific requirement, you can take the country specific FHIR spec, and then you can further customize it for your particular needs. So that's how the hierarchy of customization and profiling happens in FHIR. And that's the method which scenarios can get addressed. Hope I answered the question.
You want to ask a question? I can see your hand raised. Madhura?
Okay. Any further questions before we move on?
No, there was a request regarding sharing the extensions registry link, so I have just pinged that.
Yeah, thank you.
I hope that helps.
All right, with this, we move to the next section, which is today's section about FHIR implementation and FHIR implementers. So it is going to be an interesting session, and a lot of questions we will try to get it answered. And if time permits, we will actually see some apps FHIR does, which demonstrates the focus on implementers, right? That's the thing that means there is statement is good, focus on implementers, but where is it? How do you demonstrate it? So the demonstration is by open license, and like the license is free. The second, the FHIR maturity model, which you're seeing on the right side, right, is actually focuses on adoption, right? The FHIR resource does not mature just because the FHIR committee thinks it is mature, right? It actually goes through different levels of maturity, right? So for example, if you come up with a resource, right, say for example, patient, right? A patient resource goes through a maturity model. So first it becomes draft, then it becomes maturity level 1, and then you can read like what it means about different maturity levels, right? So if you see FHIR maturity model 5, FMM, FHIR maturity model 5, What it means is the artifact has been published in 2 formal publication release at FMM, this will be 4, and has been implemented in at least 5 independent production systems in more than 1 country. So you see that requirement, right? So if a resource or a FHIR artifact has been has first completed maturity before that, and then has been published in 5 independent production systems in more than 1 country, then only it becomes a maturity level 5 resource. So that's how the FHIR developers are guaranteeing that the resource that they are making it normative, or they are making it stable, has actually seen the production, right? And that's actually a way to demonstrate focus on implementers, right? Then there are a lot of reference implementations and libraries for the standard itself. So you don't have to start from scratch. There are a lot of reference implementations and libraries that are available in language of your choice that you can take and get started with. There are several public testing servers that are there, which can be used to actually test your implementation. So if you are building a client, for example, right, you can test against a public testing server to make sure that you are complying to the test servers or not. Or if you are creating certain resources, you can publish it on the testing server and see if your resources are getting validated or not. And a lot of things that you can do in the public testing servers. Then there is a big community, right? So a worldwide community of FHIR implementers and specification developers and enthusiasts, right? So if you go to chat.phir.org, you see everyone coming in there, right? And you just post a question and it will be answered in a matter of minutes or hours, right? And the community is very passionate about helping each other and about making the artifacts, making the implementations, making the maturity, making the spec better and better, right? And then the last one is actually the connectathons. So what if you have implemented FHIR? How do you test it out, right? How do you test out your implementation, right? So there is provision of connectathons. Connectathons are events where multiple systems or multiple implementers come together, and in a common area, in a common time, they actually test out their use cases, right, against the spec, against each other's systems, and find out the defects in their implementations, gaps in their understanding, and also maybe the gaps in the FHIR spec itself. And that's how the connectathons are integral part of the implementers ecosystem, right? So this is some of the ways with which FHIR actually demonstrates the focus on implementers.
We have 2 questions. Shall we take that?
Go ahead.
Yeah. What do you mean by 5 independent production systems? Go on the
5 independent production systems means 5, at least 5 different companies or 5 different vendors have actually implemented that particular FHIR artifact in more than 1 country.
Yeah, okay, that's clear. Another is, if you want to validate an implementation against a particular IG, for example, US Core 3.1.1, how would we approach this?
You want to, can you hold on that question for a few minutes? We'll come back to that.
Yeah, I'll ping it.
Yeah. All right. So just see this. FHIR is a platform standard, right? For implementing multiple different architectures in wide variety of purposes, right? So FHIR is such a platform, right? So FHIR is a platform standard, right? And there will be different use cases, different things that people want to do. Like somebody wants to develop a PHR, others will be developing an appointment scheduling app, somebody will be developing a vital signs monitoring, somebody will be doing bulk data export. So different varieties, right? And different architectures. Some would be doing net new, somebody will be doing ad hoc bolt-on interfaces and different, right? So the use case of FHIR and implementation landscape of FHIR is very disparate and for varying purposes. And so are the implementers. The FHIR implementers come from different backgrounds, right? and they may have or may not have exposure to the very previous HL7 standards or other interoperative standards, right? And most of the implementers may be constrained by their existing limitations of their systems, right? So keep that in mind, right? So FHIR itself is a is a platform system, the platform standard that can be used in a variety of scenarios. Plus the implementers who are actually trying to implement FHIR are also coming from different backgrounds. And that's why that community support, that public testing server support, that reference implementations, libraries, connectathons are all helping that, right? So it's not that only one type of particular skill set is required to be a FHIR implementer. So what has been seen and what has been observed is like there are various variety of skill set variants when the FHIR implementers come into picture. Some are developers like hardcore Java or .NET developers. Others are like very good experts at interface engines, middlewares, right? Others are front-end developers, fine front-end developers. So different variety of implementers are there, right? So that's why it's very, very difficult to give one simple mantra or one simple guideline for how do you implement FHIR, right? Because everyone's need is different, everyone's skill set is different, right? So keep that in mind. And with that, what we do is we come up with the guiding principles of how do we implement FHIR, right? Instead of getting to saying that do this 4 steps, right? Because that is possible only if there is the use case is fixed and the skill set is fixed. Then we can come up with a defined set of rules, right? In case of variance, what we can come up with is actually guiding principles or actually broad principles which should be followed when you are actually trying to implement a FHIR in your applications. So the first principle is test using public servers, right? So whenever you are implementing something, whenever you are building a FHIR resource, whenever you are building a client, right? Or whenever you are doing certain kind of implementation, right? Test using public servers, right? To send a resource there and see if it gets created. Pull a resource from there and see if you are able to consume, right? Do the various operations that you intend to do, right? Load an IG and load a profile and see whether you can validate against it or not. All those kind of things against the public server so that you don't have to invest in a test infrastructure. Or at least the other thing is the public test servers are actually maintained by the FHIR developers itself, the FHIR spec developers. So they are going to be good reference implementations, right? So the first general guideline is like whenever you're building something, developing something, test with the public servers. The second is if you are choosing to build a FHIR server or choosing to build an implementation application, right? See if possible to use a reference implementation already, right? So for example, if you're trying to stand up a FHIR server, right, of your own, right? See if you can use the Happy FHIR server or the Wonk FHIR server, or there is a symmetric FHIR server, or there are different FHIR server reference implementations. See if you can use them, right? The benefit of that is the reference implementations actually have implemented a lot of features of the FHIR spec, right? So you don't have to struggle with that. Similarly with the client also, right? There are FHIR-client.js and other things that are available, right? So see if you can use the reference implementations, right? So do not, so first is use test servers, use reference implementations, and you know that, that the client will be easy, but the server is way harder because FHIR as a spec pushes a lot of requirements on the server, okay? So the server needs to support the operation, server needs to support the security, the audit trail, everything about the resource, right? So servers are tough to implement, FHIR servers, whereas the clients is easy because all the client has to do, and I'm just understating, but it's actually has to send a request to the server, receive the response, and then act on the response, right? So clients are relatively easy to than the servers to implement. So just keep that in mind. Code, so there is also a tendency that code generation from the spec that is available, right? So you can download the JSON spec or the XML schema from the FHIR website, and you can actually generate your codes, right? But code generation has a limitation because the schema generally contains just the structure definition, right? And it misses out of all the other nuances of it. So while code generation from a schema is fine, but just make sure that your code actually complies to the FHIR spec, because there are scenarios where the schemas are not enough, right? And the last but not the least, whenever you have implemented your application, just make sure that you go through the implementer safety checklist. So implementer safety checklist is also published by the FHIR spec itself, which makes sure that you don't miss out on the basic hygiene stuff when it comes to the clinical safety and the security of your application and the patient, right? So these are the broad guiding principles that you're keeping in, okay? And I think 555 rules everyone is aware of. And this I just inserted in here. I think it feels out of sync. But the 555 rule says that if you want to find the FHIR spec, so for example, patient observation, you just search FHIR and observation, you should find the spec in 5 seconds. If you just, and we saw that again, like when you're reading a resource or artifact, if you understand its objective and the purpose, you have understood what the resource is. So FHIR focuses on trying to make sure that the implementers understand what the resource or what the artifact or what the particular operation does in around 5 minutes. And they are able to develop or make something in 5 hours. So that's the goal of the FHIR developers or the FHIR spec makers, right? So they want to push to the simplicity where like anyone should be able to find the required information on the net and should be able to churn out something in 5 hours. So that's what the FHIR developers are trying to do. But keep in mind that actually developing something in healthcare requires 5 years, but that's just an add-on. But here the 5-5 rule is where the FHIR developers are focusing on, and that's where the emphasis on implementers is. All right. So, okay, enough of theory and enough of principles, right? Now let's get into what as a developer or an implementer of FHIR we need to do. So first of all, if I'm a business analyst or if I'm an architect or if I'm a developer, right? What is the first thing that we need to do is first identify the resources that we need to implement, right? And then we need to actually see like what models need to be supported. Should we support push or pull, right? For example, push is when a client actually pushes the data to the server, right? So for example, creation of a resource, creation of an observation, creation of encounter, right? Those are the push mechanisms, right? And pull is when somebody does a request and you give the response back, right? That's the pull, correct? So FHIR supports both push and pull mechanism, right? Then as a developer, our first thing that we need to think of is, should we be doing push or pull, and what should we be doing, and how should we be doing, right? So push versus pull, right? So what should be push, what should be pull? FHIR also supports subscriptions, right? I have not included that subscriptions in here, but actually there is a pub/sub mechanism also available, right? Where a client can actually register for a subscription, right? And then when that particular event happens, the client gets notified, right? That is also possible, right? So when you're implementing, think of whether you want to implement the push or the pull or both, or even the pub sub, right? So that's the first thing that you need to think apart from the resources that you have identified. Then the second, the other thing that you need to think about is FHIR formats that you need to support, right? Should you support just JSON or should you support XML, right? Or should you support RDF and NDJSON and all those things, right? So as an implementer, you need to think of it, right? What formats do you want to support, right? And whatever format you decide to support, you need to put them in your capability statement so that if a client or a server wants to connect to you, the first thing they do is actually they get your metadata, right? So the first interaction that any server or any client does with another server in FHIR case is they hit the metadata endpoint, right? So it's the base of the server / metadata, and it gives you the capability statement. And the capability statement contains the entire capability of that particular server or the client, right? What format it supports, what version of FHIR it supports, who is the developer, what resources are supported, what search operations are supported, everything, right? So you need to list out your format supported in your capability statements. Clients and servers can choose what syntax to implement. So FHIR does not specify what format that you need to support. So you can choose to support JSON, or you can choose to support XML, or you can choose to support both, right? But the general principle is, as a server, it is good to support both XML and JSON format because you don't know how the client wants to connect to you, right? And client can be just a mobile web application, right? So there will be less flexibility on the client end, right? So if the client just supports, say, JSON and the FHIR only supports XML, then there will be a problem, right? So typically the servers support all the formats, and the clients also do support XML and JSON, but they lean towards the JSON aspect, right? If it is a web app or a mobile app, generally the leaning is towards the JSON format, right? The turtle and the bulk data format are specific use case formats, but for majority of the exchange, JSON and XML are the ones that are used. For more details on the formats, refer to the link below, hl7.org/FHIR formats. All right. So we talked about the clients and the servers, right? So the RESTful APIs or the RESTful paradigm actually divides the world into two, either the client and the server. So a FHIR application, so even whatever FHIR application you choose, right, it will either be a client or a server, right? So that's the RESTful paradigm of RESTful paradigm, right? So it will either be a client or a server. Clients typically are lightweight applications. They issue CRUD request to the server, and then they do response. They process the response and render on the user interface. That's what the clients typically do, right? And in addition to logging and authorization and other things. But if you remove all those things, these are the things that the clients do, right? What do the servers do? Servers deals with the complexity. Servers deal with the security, threading, performance, multiple representations, searching, indexing, storing of the data, everything, right? The servers deal with it, correct? So that's why building a FHIR server is more complex than building a FHIR client, right? So choose your use case, and then depending on that, think what makes sense and go for a reference implementation if it helps. All right. So since we have seen that, so let's discuss a little bit about implementing a server. Okay. The first thing you need to know is choose what services you want to offer, right? So as you know that in FHIR spec, everything is optional, right? So what it means is a server can choose to support the functionality that it wants to, right? And the first thing as an implementer of a server needs to do is actually think of what all services you want to support. Now, there is one requirement for a server, that the server minimally must support one resource, right? This is a poll. Can you answer the question? So what is the minimum requirement for a FHIR server to support? Please, on chat, you can give the answer. What is one particular resource or one particular operation that a FHIR server must support, and rest everything is optional? Yeah, I think majority of the people have given the right answer. So good. So it means that you guys are paying attention to the trainings, and that's a good thing. So conformance statement, you're right. So a FHIR server should minimally support a conformance statement, because the conformance statement is the starting point. Conformance statement actually tells the world what all things you are capable of. So conformance statement must be supported. Okay. Decide what resources to support. And for all the resources that you have supported or you choose to support, make sure that you support the get and the search functionality, right? Because without the get and the search, there is no use, or there is less usability of the resource that you're supporting, right? So should always be provided. Get and search should always be provided for the resources that you are supporting. These are just guidelines. Okay, right? Do you want to support write? It's again a choice that you need to make. Delete, again a choice that you need to make. Versioning, we have not seen many servers supporting versioning, but versioning is a good thing to maintain because it maintains the historical perspective. Okay. So there is a question that always comes up, and it's mostly about the internals, right? Should I be using a database? Should I be using Java or .NET? Should I be using microservices? A lot of questions, right? But remember, APIs are the external interface to the world, right? So for a third-party application, it doesn't matter, right? Whether you have implemented in Java, JavaScript, or you have done a database, or you have done, what do you say, interface engine and all, nothing. As long as you're exposing your APIs, you're exposing your capability statement, and you're exposing your resources, right? They just care about that. So then just know that there is a server URL, there is an endpoint for a resource, and these are the operations that need to be done, right? Internals do not matter, and internals are irrelevant for Exchange. So just keep that in mind. When you're dealing with APIs, for APIs are the contract to the external world. Internally, what you do, no one should be bothered about it, outside world. Okay. So you can choose to implement using an interface engine if it makes sense. You can choose to implement via just a database, right? Or whatever you want to make sure, right? It should not bother anyone else. The botheration for you should be, how do you support security? How do you support performance? How do you support scalability, right? Those should be your concerns, right? Nothing else. So this fact should be kept in mind, that APIs are the interface to the external world, not your internal implementations. And no one outside should be bothered about your internal implementation. Okay, implementing a FHIR server. What we have seen is first, how many FHIR servers are there which are grounds up, means which just basic FHIR, means pure FHIR servers, speak natively FHIR, right? I think they are rare, right? Means in production, there are rarely native FHIR servers. So not much. Because, and the reason for that is there are thousands and thousands of healthcare applications, healthcare servers, healthcare system already in the field, right? And no one is going to throw away the existing systems and just put in a shiny new FHIR application. No, that's not going to happen, right? So what we are seeing and what we have seen mostly so far is there are bolt-on interfaces happening, right? So what it means is you have the legacy system and you make them FHIR compliant. This is what is the trend right now, okay? And generally, these are the few strategies that are being followed. First is use interface engines, right? So that is the quick and dirty way, right? So HL7 message is coming. You need to convert that HL7 message into a FHIR bundle. So a bundle, if you don't know, a bundle is a resource which can contain multiple resources, right? So if you have to support a group of resources in one package, bundle can be used, right? So interface engines are being used in many places to convert HL7 messages or different proprietary formats into FHIR and then expose an endpoint and then support basic operations like post to a FHIR server. Or if there is a support for a read, you can support a simple basic read, right? So we have seen that. FHIR facades are coming into play. FHIR facades are actually like servers like Happy or Wonk, who are full-blown FHIR servers, but then they don't have their own FHIR stores, but they actually connect to the databases that are there with the healthcare systems. And then there is a proprietary data extraction manipulation logic that gets written so that for the external system, your system is FHIR compliant. While you have not internally changed much, you just put in an external server, and then you have made your database connect to that, right? That is FHIR facades. And that is also, we have seen a lot of EMRs and EHRs doing that. Then there are systems, what they do is, they see, like we don't need to have direct transactional connection with the external world. So what they do is, they actually put their data into a common database, and then on that, they actually put a FHIR facade, right? So their transactional system is not disturbed. The data that needs to be exposed as FHIR, they actually put it into a centralized or a general purpose database and then expose it as FHIR. And this can be used for, you say, for read-only services or services that you are exposing for, say, research and other purposes. This is a practice that I see happening. Then slowly we are also seeing gradual adoption of FHIR by components. So where the application developers are saying, okay, maybe this component makes sense to be natively in FHIR, right? And we are seeing components having hybrids, right? So there are certain components which are really being developed in FHIR, and where other things remain in the proprietary or the old format. That's also happening. And so as an implementer, you can choose any of the models that work for you. So the point that I'm putting these things in front of you is to make sure that there is no right way, or there is no the way of implementing FHIR. So you have to choose, or you have to think about your scenario, your situation, and what best works for you, right? And go ahead and do that. Over a period of time, there should be a transition strategy. Over a period of time, you should have a way to transition over to more and more FHIR compliant systems as you see the need. Okay.
Satyam, I think we need more clarity here.
Go ahead.
You said there are rarely any fresh ground up FHIR server, but then what are the free servers available? Are they not FHIR servers?
They are, I'm talking about the public servers. So there, how many public servers are, so how many test servers are there, right? Few. But in healthcare, they are test servers again, right? In production, right? When you are talking about hospitals, right? Institutions, right? Who are actually working with patients, right? I'm talking about those scenarios, right? So your public servers, the public test servers are good, and they are native implementations of FHIRs. They are very good, but they are not used in production, right? Means they are not used in care setting, right? They are still test servers. You getting my point?
Yeah. Yes, I think that is clear. Okay, he also wants something about facades and CDR again.
Can I add a point over here on the public test servers? The public test servers do not implement storing of the data. The entire data is stored in directly in in-memory variables or an in-memory database. And that is the reason why if you look at the public test servers, if you store data today, there's no guarantee that it will be there tomorrow. So that is one thing. And second one is, as far as facade is concerned, you could look at Happy FHIR servers. They have quite an amount of write-up on facade.
So coming back, just a small add-on to what Arun said. So we can't say that the FHIR servers, the public test servers, do not have a database of their own. They do store data, and but they do regular cleanups, right? So since the storage is limited, there are frequent cleanups that happen, right? So, and you don't know the schedule of them. But having said that, the point that was to be made was that in production, in real healthcare settings, right, we have not seen much native FHIR server being used, right? And the reason for that is data is already there, right? And that data needs to be exposed or be FHIR compliant, right? That's the use case that we are seeing. And that's why we are saying that these are the certain ways where FHIR is being incorporated in the real world, right? So what I'm not saying, and please don't misunderstand me, that FHIR cannot be used. Definitely FHIR, plain FHIR servers or just FHIR only servers are good use cases. We have seen situations and systems where if you just want to make a data store, right? So you are just getting data from outside in FHIR format, and you just have to store them, right? You might choose to just use the native FHIR formats, right? But the point that I want to make is, in today's scenario where the healthcare enterprises are already having data and they want to transition onto FHIR, they are using these approaches. And these are few of the approaches that I have listed out. There could be more, okay? Now coming to the facade was the question. Facade is just a front face. So you can think of a facade as a front face. So what happens is the facade, and it's the architectural facade, if you can think of it, right? It's the outside view, right? Inside, what happens is not important. Outside, it gives FHIR to everyone, right? Internally, the facades, what they do is they actually connect to your database and then read the data, or maybe do CRUD operations, then convert the data into FHIR format and expose. Or when the FHIR data comes into the FHIR endpoints that is exposed by the facade, the data is received, data is converted into, say, database queries, and then inserted or updated onto the internal data store. Okay, that's the facade. And maybe Avanti, we can put that link on facade more, right, in the discussion forum. So I'll just find a link for facade, and he can just read about Happy Facade server that Arun also mentioned, right, to read more about it.
So, yeah, just mark that.
So, sir, you mean that facade is just reading the data, for example, from the database, on the fly, they convert into the FHIR resources and then display?
Yes, facades can be for reading and writing both, but the idea is the data is still in your database, in your transactional database.
No, but again, in the middle, there should be some, like, for example, when they are converting the data from the simple.
That's the facade is doing. So facade will connect to your database. So you'll have to write data manipulation and data query things, right? Which will extract the data from a database, convert it into FHIR format, and then expose it, right? That's the entire facade model.
Yeah, but again, I mean, the middleware is also doing the same.
Yes, so the middleware is for limited things, right? So for example, so you can use middlewares also, but middlewares are limited in scope, right? So in middleware, you have to write everything with your hands, right? So for example, in a patient, you have to search 20 search parameters, right? Or I don't know what is the number of search parameters that you have to do, plus the plus the reference includes and all these things, right?
Yeah.
In middlewares, you have to hand code them all, right?
Yeah.
Whereas in the facades, those things are already pre-built. All you have to do is connect data, right? So that's the basic difference. But you can use middlewares. Middlewares are nothing, but they're also a kind of facade, right? They're also a kind of facade.
Okay, sir.
Satyam, one quick question. This
Yeah.
As you mentioned, it is rare. So, like, by any chance, or any EMR implemented this FHIR server so that these FHIR servers are exposed to be in use?
Yes. All the major EMR servers are using FHIR, right?
Example, is Cerner using it?
Yes, Cerner has a FHIR. So again, Cerner exposes its data as FHIR. All right.
Okay.
Now, whether it is using a FHIR facade, which most likely it is using, right? Okay. So Cerner, Epic, Athena, NextGen, everyone has a FHIR interface.
Okay.
Right?
So they do have these FHIR interfaces with.
Yes. Okay. Now, as we said, right, internals are not our botheration, right?
Right. Not internal. I'm not talking about internal.
So all the major EHR vendors have FHIR capabilities.
So please correct my understanding. If they have FHIR capability, so if I have to use, those EMR is already in the premises, let's assume, and I want to write, let's example, some exchange or some patient portal for the data which is dependent on the EMR feeds. So I can very well use FHIR client to connect to this FHIR server and get whatever data I need or to update.
Yes. Ideally, you should be able to. So how it's happening in the different EHRs like the Epic and the Cerner and one and maybe Athena also, is they have their own developer programs. Okay. So you go in there, you register there, right? You get the client ID and you need their application client ID and the client secret, right? With which you can authenticate and authorize to use their APIs, right?
Correct. REST API.
And once you take that, you can use it.
Oh, okay. So simply
so
authentication details I need, and then I can just query the resources I need and everything, right?
Yes. So they follow mostly a Smart on FHIR spec, right? So we'll cover Smart on FHIR also at a high level, but they generally use Smart on FHIR. So Smart on FHIR is, so if you see FHIR, right? FHIR is not a security spec, right? FHIR does not talk about security. Right?
Correct.
Smart talks about security. So when Smart and FHIR meet, right, they become together they can be implemented for existing healthcare applications, right?
Okay.
So generally, the OAuth, the authentication, authorization, the scopes, the launching is taken care of by Smart, and FHIR is all about resources and other things.
Okay. About data.
Yes. And API.
Okay. Thank you. Yeah. Thank you, Satyam.
Okay.
Satyam, I have posted examples of Cerner.
Oh, can you repeat the question?
No. I have given some links for Cerner FHIR, public FHIR, and Smart on FHIR. That's a good starting point for anybody to.
Thank you. So one request I have to make, since we are recording this, right? So maybe we can have timed conversation that will help the recording go smooth. All right. So the next, just keep one thing also in mind, that FHIR servers may not return you the resource the way that you send it. So maybe, so what it means is the receive and the send. The client might send a FHIR resource, right? And when the server, when you do a get of that particular resource, right, that you created, there might be differences, right? So the resource content might differ, okay? So FHIR spec does not mandate that as you receive, you should serve. That kind of mandate is not there. And there are a lot of reasons because of that. And some of the reasons may be because of security considerations, because of privacy considerations, right? And also because you see you're connecting to a lot of legacy databases and legacy services, right? It may not be possible to actually persist all the elements or all the things that the client sent, right? So there could be a lot of reasons, and that's why the FHIR spec does not mandate the server to return the resource as is, right? Which is a powerful thing, right? So which frees up the server to actually take some decisions based on the access, based on the privileges, security concerns, and also based on the internal data models, right? So keep that in mind. So if you are not getting a resource that you sent exactly in the format that you sent, it does not mean the server is behaving abnormally. Okay. So, and for more details, you can go to the link that is there, updates, to read about it. All right. So that brings us to the question about storage. Okay. So we talked about resources, we talked about APIs. Now we talk about storage. How do FHIR servers store data, right? And we saw that most of the FHIR servers actually, they might be storing the data back into the traditional transactional databases, or they might be storing into a common database. So again, the choice is again depending on the FHIR server that and particular use case that you have, right? So you can choose how to store. So certain EHRs and EMRs can actually implement saying that I will store in the transactional database itself. But we have also seen hybrids, and hybrids are the most common ones, where the JSON or the XML is persisted in a document store, but the metadata or the searchable parameters are actually persisted in RDBMS format, right? So that your queries are faster. And when you have to return the results, you return the JSON or the XML. Now keep certain things in mind when you are doing the storage. And again, you can read more about the storage.html at the link. But the thing is FHIR, and this is a very, very detailed discussion that always happens, right? What is FHIR, and should we build a data model based on FHIR, right? So keep this in mind. FHIR is a data exchange standard at base, right? So FHIR is meant to reliably exchange or send data to and receive data from a system, right? And FHIR does that perfectly. And for that, there is a lot of structure that has been built into the FHIR spec itself, right? So for example, if you have to send just say line code for say, what do you say, blood pressure, right? So you're not just sending the code, you have to send the system, you have to send the display, you have to send, so coding, in that coding, you have to send system, display, code, all those things, right? So that the receiving system actually understands what you're sending, right? But when you're persisting, you don't need to persist all these things because you know that it is always going to be long, right? So you'll just put the code in, right? So for storage, what I'm trying to say is persisting entire FHIR structure may be an overkill, right? Because for one attribute, which is just a code, right? FHIR is actually having 4 to 5 additional attributes to support that, right? And if you're persisting everything, actually you're adding up to your storage, right? So what to do? There is no answer to it, but the heuristic says if you know your use case very well, right? And if your data model is very, very well defined, right? Stick to your data model and just use FHIR for exchange. Okay, the data that you receive, parse the data, put the relevant in your data model, right? This will work as long as you understand your use cases and you understand the scope, right? Everything is fixed. But if certain things are fluid, and if you don't know your use case, you don't know what data you might need tomorrow, and certain things like that, in that case, maybe start with persisting the FHIR data model itself, because FHIR has extensions also, right? So it actually gives you leeway to extend your data model going forward, right? But again, it will be coming up with a lot of extra storage space and extra computing that you need, right? So again, there is no clear answer, but the thing that we have seen is, if there is an EHR system, if there's an EMR system which understands what exactly data that it needs to persist, it actually persists that and it discards everything else. Whereas if there is a data repository, clinical data repository, or certain system that needs data for future use, what we have seen is a hybrid data model being stored, where certain pieces go into the relational database and the FHIR structure gets stored on the blob, right? Another thing that might be a concern is what happens. See, in FHIR resources, there are a lot of references, right? References to other resources. How do you make sure that your references are always intact, right? Those are certain questions or certain things that make, again, the implementation choice a little difficult. And now you're getting my point, right? Why implementing a FHIR server might be a little difficult than actually a FHIR client, because a FHIR client is a FHIR client. It just does a few operations, right? So read more about the storage. So storage, again, there is no answer, and the answer is depends on you. And the FHIR standard itself is flexible enough for you to decide what you want to do. So there is no wrong, right, answer.
And sir, I have a question. Should we have a special FHIR database, or we store the data in simple RDBMS, like the Oracle and the SQL, something like that, MySQL, something like that?
That's what I answered, right? So you can choose what you want to use. So you can choose to have data stored in a blob, like in a document store, right? Or you can use RDBMS like Oracle or MS SQL or MySQL to store data.
No, my question is, should there is a special FHIR databases available?
No.
I mean, that which is special for the FHIR server. I mean, FHIR data.
No. There is no database like that.
All the developers are still using the RDBMS, simple RDBMS, either Oracle or MySQL or stuff like this, right?
Or Oracle, no. So I'm saying they are using either data RDBMS or they are using the document DB, right? Like, for example, MongoDB.
Okay.
Right. So a combination of RDBMS and document DB is what is being used, and in-memory databases are also being used, but that is only for testing and all.
Yeah, and my second question is that either, I mean, when we are storing the data there in the database, for example, we are using the RDMS, for example. So either the data would be stored for the data will be retrieved from the resources, and it would be stored in the database like the simple attribute, or we can store the whole resource. I mean, in the XML file or the JSON format in the DBM in the database.
You can store that. You can store in blob. No one stops you that. So you have to think of the performance considerations, right, when you are doing that.
So we can store the whole resource there in the database, right?
Yeah.
No, but but again, the question is that, I mean, when we are storing the whole database, the whole resource there in the database, so before we said that why we use the like I mean, most of the like the Microsoft right now, they are using the Excel sheets there. They are converting the resources into URL, and they you store the URL there in the Excel sheets. I mean, therefore for the transactions or for the middleware, I mean, for if they wanted to transfer the data from one format to another to the FHIR standard, for example, like the simple EMR data to the FHIR standards, so they convert to the FHIR resources and store the links there in the Excel sheets. And the receiver, and they are retrieving the data from the Excel sheets. I mean, the length from the Excel sheet like this. I mean, in the middleware, like we discussed before that in the middleware, how in the exchange the data between two systems, like the FHIR standard and the simple EMR or the HL7 version 2 standard, for example. So in the middle, they will use some sort of mechanism like Excel sheets. When they convert the data to the FHIR resource, then they store the links over there in that sheets, and the receiver end, they retrieve the links from there and transfer to their own system.
Okay.
Yeah.
I think it's a specific scenario. Maybe I did not understand it completely, but we can take it offline. Okay, after the session, we have time to discuss. We can discuss there.
Oh yeah. Okay, sir. Sorry for this.
Okay.
Okay, sir.
All right. So coming back. Let me go back. Where am I?
Satyam, can I ask one small question? I don't want to.
Yeah, go ahead. Go ahead.
As we discussed before about coupling the FHIR server with EMR, okay? Because end of the day, this FHIR server need data, right? So it has to connect some EMR HIS somewhere to get the data.
Right.
So when FHIR client is trying to get data, they will be invoking those URLs or URIs we can call. So since these FHIR servers are tightly coupled or with EMR or relying on EMR to get the patient, healthcare data. So in that case, why do we need a separate storage for FHIR server?
You do not. So only in the use cases where you're implementing a FHIR server standalone or for some other purpose, right? You need a storage. Otherwise, you are using.
That I understood. So that is my question. So if we don't have a data, so like what is the source of data? Because FHIR server cannot run independently, right? It can run technically, yes, but the source. What is the authenticity of the source data in the server?
So I think again it depends. So you are thinking
I'm just
you're thinking EHR as a source of data, right? You can have a FHIR server, okay, which you stood up grounds up, right? And it is just becoming a FHIR server for your wearables, for example, right? In that case, all your wearables are doing is sending data to your FHIR server, right? So it doesn't have a EMR interface right now. Right.
Okay.
Means there are use cases where you can think of, right?
Where we are building our FHIR server, so we are feeding the data to FHIR server, and others can consume it. Okay. Okay. Thank you.
Yes. Not for the traditional ones where already data is there. I don't think you need storage, right? But yeah, if you're doing something fresh and something for a certain use case where you're feeding the data to the FHIR server, yes, makes sense.
Okay.
Right. Okay. So because we are seeing also scenarios where a lot of use cases are coming in, right, where wearables or field testing devices, right, are directly sending data to the FHIR server. They don't interact with an EHR, right? And from the FHIR server, then they are building some smart apps on top of it, right? So those kind of things, they need storage, right? But they're disconnected with EHR.
Yeah, they are disconnected, but logically they are connected, not in that way, right? Through FHIR server, the data are connected. Basically, you can come up with some relation between the data.
Yeah,
am I right?
May not be, because the use cases are like just one pharmacy vendor, right, or clinical trials vendor, just wants to store all the clinical trials data in a FHIR store, so that tomorrow he can build an analytics application on top of it.
I see. Okay.
In that case, he does not need an EHR, right?
Okay. So it will be just push mechanism from those applications, and it is just storing it.
Yeah, and FHIR for analytics is picking up, right?
Okay. Yeah. So this is basically different use cases where we have to think about based on our use cases.
Yes.
Okay. Thank you.
Okay.
Yeah.
So moving next. Okay. So we talked about the security checklists, right? So safety checklist. So you have built, so remember, like FHIR, if you read closely, right, has actually built on top of a lot of industry experience also, right? So you remember the versioning, the invariants, the modifiers, all those things are actually certain kind of safety checklists that are in place in the FHIR spec itself, right? But given even that, right, there is also the FHIR spec publishes a safety checklist, right? So whenever you are beginning to implement FHIR, right, for an application, or you have completed your implementation, it's a good idea to actually run through that implementation checklist or safety checklist. Okay. The safety checklist actually talks about a lot of things like, for example, I was talking about the modifier. That's the first line item itself. So you know what is a modifier? A modifier is an attribute which changes the complete meaning of the resource, right? For example, status in case of a resource, right? If the status is inactive, means that resource is no longer to be used, right? So as an implementer, have you paid attention to the modifier elements? Have you paid attention to the modifier extensions? Are you handling the status codes, concurrency, error scenarios properly, right? So there is a checklist that the FHIR spec has given, right? When you go through that checklist, you are actually sure that you are not writing just a technically correct application, but you're also writing a clinically relevant or clinically safe application, right? That's what the safety checklist does, right? It actually helps you go through one more round of clinical safety iterations, right? Similarly, for security related checks, like for example, are you doing the encryption? Are you doing the authentication authorization? Are you implementing access control? What are the methods you have put in place to check for integrity? Are there audit logs? Is there provenance resource, right? And so many things, right? So if you go to hl7.org/FHIR/safety.html, there is a checklist. And if you go through that checklist, you might be relatively sure that the application that you have built is clinically safe, right? Not 100%, but it is better, right? So because as developers, as implementers, as business analysts, right, we actually take care of certain aspects, but may miss out on the clinical safety, right? So it's good to go through the clinical safety checklists, right? And the checklist is part of the spec itself. So you don't have to go anywhere. Got my point? All right. So now this done. So what are the tools for implementers, right? What are the tools that are available that you can leverage and use? First is the test servers that you have seen and the link for the test servers. So there are plenty of test servers. You can go to the link and see the test servers. Validation tools, right? So you know the validation jar, right? So using which you can validate a particular resource for a particular profile in the IG, right? And it also does the conversion, and it also does a lot of things. So there are validation tools. Then there are open source reference implementations, not just the server, but also the client, right? You can make use of them. Then there is a FHIR registry. What is a FHIR registry? FHIR registry is the registry of all the implementation guides and all the profiles published, right? So you can take a look at the registry and figure out whether the profile or the IG exists or not, and you can actually validate against those also. Then there is a Notepad++ plugin. So if you are using Notepad++, you can actually install the Notepad++ plugin, and then what you can do is from your Notepad++, you can actually validate, create a resource, validate a resource, send the resource to a server, highlight the syntax, a lot of things you can do with the Notepad++ plugin. So I did try a few of them, and I still have to figure that out. But I think it's a powerful thing. You don't need anything. So if you are just doing something, some POC, or if you are doing certain quick checks, right? You don't need anything. If you are using Notepad++, I think you have a plugin for doing that. In our FHIR discussion forum, right, the HL7 India FHIR discussion forum, we have maintained a list of useful links, and there are plenty of them, right? So, and that will help you going through a lot of resources, which will be handy for implementation. So take a look at them. And if you find certain links which are useful, please add those links also there so that it can help others, right? So, and this is just a reference list. There is a lot more. So you can just go to FHIR tooling ecosystem. Again, there is a link for that. And you see all the tools that are available. All right. So last section that I wanted to talk about was FHIR security. I know it's a big topic, but we will not go into details of it. A few things that needs to be kept in mind. The first, FHIR is not a security protocol, right? So what it means is there are guidelines and there are standard security protocols that needs to be followed. So FHIR lists out all the things that should be taken care of. So for example, time check, right? So that is one thing that I see being ignored a lot, right? So, and this is because we have taken granted, because all our times are generally synced with NTP or SNTP server, right? But think of servers who are like not synced with the NTP servers, right? So they might go off time, right? So even if a time sync a lag of 5 seconds or 5 minutes might give wrong interpretation, right? So you created a resource at 4 o'clock, but at the server, it's only 3 o'clock. There will be a problem, right? Or the time zone is different. So you created something in IST, but in the server, it got stored as, say, CT time zone, right? It is a problem. So time checks, for example, communication security, right? Use of HTTPS, authentication, right? So how make sure that your data is only accessed by the authorized and authenticated agents, right? Then audit digital signatures, attachments, labels, narratives, input validation. So there is a huge checklist or huge things that you can, again, go to the FHIR security and take a look at it. And on the right-hand side, what I have shown, and this is also from the FHIR spec itself, is what are the typical ways or typical architectures, right? How security gets implemented, right? And these are typical ones, right? The first one is actually the security, the gear, right? The gear icon, right? This one. This one is actually the security system, which takes care of authentication, access control, and everything, right? So that might be in between, right? So that can be a separate system altogether, which sits between the client and the server, and which does take care of authentication, authorization, everything, right? So that's one way of implementing security, and that happens, right? The second one is the client takes care of all the security, right? And then sends the data to server. I don't know how useful that will be, right? Because the data in transit can be compromised, right? And the third one is actually the server has all the security mechanisms with it, right? So the client just sends the request to the server, and the server does all the validation and all. So these are typical security architectures that can be implemented. The red lines are actually the FHIR interfaces. So these are the typical architectures that can be implemented. And there could be others as well, but these are the most prominent one, I guess, because the FHIR spec also mentions these only. So what it means is like you can think of where to put the security also, and you have to again make a decision. Where does it make sense for you, right? So keep that in mind, and keep security in mind. The security is paramount, because we are dealing with clinical data, and if security is compromised, everything is compromised, right? So though FHIR does not mandate, is not a spec for security, or does not specify security related aspects, it does recommend to use all the standard security protocols, right, that are defined. Okay. And with that, with security in mind, let's get on to Smart on FHIR. So Smart on FHIR, right, is actually a spec, right? It's an open specification, just like FHIR, and it adds on FHIR. It adds a layer on FHIR on and dictates how you should be integrating with existing health systems. So if you have for example, if you have a third-party application which is FHIR compliant, right, and it wants to interact with an EHR system, right? So you have developed a mobile app, right, for example, and you want to interact with Cerner or an Epic FHIR ecosystem, right? You would be using the Smart on FHIR spec, right, which will dictate or which will tell you how to actually integrate with the ecosystem, how to do the authentication, authorization. It talks about the scopes that are permissible, right? What are the scopes? The scopes are like, so there are various scopes like patient scope, user scope, practitioner scope. So there are different scopes, and for each scope, there are different access privileges, right? So Smart defines those scopes and also says, like, for each scope, what are the permissions available? And then it also gives you a guideline about how the consistent integration of the UI can happen, right? So in short, FHIR gives you the APIs and the data, right, and the operations, and Smart provides you the integration mechanism and the security and authentication, authorization, and the scope launch mechanisms, right? Together combined, it becomes a powerful implementation tool. And if you see, Smart on FHIR is mandated or being used by everyone. If you see here, if you go to 2019, CMS says Smart on FHIR. Then ONC rules 2021, they are asking for Smart on FHIR. Apple is using Smart on FHIR. Cerner is using Smart on FHIR. So everyone is using Smart on FHIR, right?
Can we say that it is like a Google Play Store for the FHIR?
Google Play Store is actually listing of apps, right? So where you list your apps, right?
Yeah.
So
the Smart is also provide a platform for the apps.
Smart,
right?
So hold on. Smart is a specification. It also has an app gallery, which can be looked at as a Play Store. Okay. But Smart in itself is a specification, right? And its app gallery is the listing of all the apps which are compatible with Smart specification. So now what we can do is we can take a look at the Smart apps, right? And okay, so first let's take a look at the next steps, and then we'll go to see some Smart apps, okay, to get an idea of if you are trying to build a client, right? You can actually download a open source Smart app and try playing around with it, right? That will be the easiest way to actually get onto building a Smart app, right? So we'll see some of them, right? So okay, next steps. What should you do now, right? So the thing is, whenever the next Connectathon happens, right, just participate in there. What the Connectathons do is actually you meet a lot of folks who are actually implementing FHIR, who are there to test their implementations. So, and what happens in Connectathons are there are different tracks, right? And each track is focused on a specific use case, right? And depending on your use case, whether you want to learn about FHIR itself, or you want to implement bulk FHIR or Smart, there are different tracks, right? You can get enrolled into that track, and maybe there is a track for DaVinci, and there is a track for Karen and all, right? So you can participate in those tracks and actually learn a lot, test out your specification, clarify your understandings, and meet and build relationships, right? So participate in Connectathons. Connectathons happen like 3 times a year in the HL7 international ones. HL7 India tries to do once a year. So far, we have not been doing for this year, but the plans are taking shape, and maybe in the later part of the year, we will have a Connectathon in India. So do participate in the Connectathons. There is a GitHub repository where there are FHIR starter projects in multiple languages. Go to that GitHub repository, download a FHIR starter project in your language of your choice, and experiment with them, right? If you are starting with the requirements, right, map your requirements to FHIR. Use clean FHIR to actually play around and build scenarios around it, right? Try out the tools that are listed, right? So try out the public test servers, try out the validation tool, try out the simplifier, right? Just try to understand them, right? Join the FHIR implementer community. Join the FHIRindia.zulipchat.com. Join the chat.fhir.org. Try, learn, implement, and share, right? So the only way from here is actually you start trying out things, and then wherever you get stuck, you reach out, you figure out the answers, and then once you implement, you share that with the learnings with everyone, right? So that everyone understands. Right? That's the way to go forward. And coming back to the trainings, I think this FHIR basics training, one of the intent of this training was to actually make sure that help folks understand that how to get started with FHIR. That was the intent of this FHIR basics session that we had for 5 series. And it was intended to be just 5 hours, but we actually took 10 hours, right? But the intent was just to make sure that you are comfortable with FHIR, you know the basic concepts of FHIR, right? And you know where to get started, right? And if you are comfortable with doing that, I think you have achieved the goal of this series, right? And we have been successful in providing you the basic knowledge of making sure that you understand where to start in FHIR. What are the questions to ask? What are the resources to look at? And understand what are the basic terms and terminologies, right? What is a resource? What is an API? What is a search parameter? What is a profile? What is a FHIR server? What is a capability statement, right? If you understand these things, I think you are better off than majority of the people who are actually trying their hands and trying out to learn FHIR, right? So you are way ahead. Now build on top of that. Now try out certain projects, and maybe our next sessions, whenever it happens, it will be actually on some projects, right? So we will actually try out certain projects and try to implement them, right? I can't promise any timelines, but whenever it comes, we will be doing something of that sorts, right? So if you have any questions, we can answer that. And then we can actually take a few minutes to go through some Smart on FHIR apps and see them, how to use. So if there are no questions, what I can do is I can stop the recording and
so we do have. Is it okay?
Go to where?
To the Smart App Gallery.
Okay.
Yeah.
So what we can do is, okay, before we go in there, there are 2 requests that I have. Okay. The first, are you guys listening? Okay. If you are listening, what you have to do is you have to help me make sure that the FHIR India community grows, right? Because the more vibrant we are, more diverse we are, more useful we will be, right? So the request for everyone is to actually share few lines about FHIR India community on their social media channel, on LinkedIn, right? Today, with hashtag FHIR India, right? So that we can take a look at it, or we can actually help promote it, right? So that's one of the requests that I have. Do write some lines, some things about FHIR India community. Maybe you can talk about the training, you can talk about what's happening with FHIR in India or anything that you want, right? But do a hashtag of FHIR India so that the word spreads and more people know about FHIR India community, right? Maybe we'll find few more guys who are interested, few more guys who are interested in sharing knowledge, right? So that's a request, do that. The second thing is, if you have not still on the Zulip channel, please be on there, because tonight it is going to be invite only. And after that, it will be very difficult for folks to get on there, right? So these are the two requests that I have. With that, I will move on to the Smart App Gallery. Okay, so the full form of SMART, did you notice that? It's substitutable medical apps and reusable technology, right? That's the full form and that's the motto of SMART. All right. So this is the link for Smart App. If you go here, smarthealthit.org. Okay. And then if you go to App Gallery, this is the Play Store that Ayaz was talking about. Okay. So there are a lot of apps in here, and they're smart compliant apps. Okay. And if you see here, you have the search criteria, and actually you can see EHR support here. And you can see which EHRs do the app support. So if you search for, say, app supporting all scripts, right? So these are the apps that work on all scripts. Okay, ready-made. Okay, and similarly, you can think of it. Then you can also see FHIR version, right? So R4, how many apps are supporting R4? And you can take a look at it. All right. So today, our interest is we go to the pricing, we go to the open source apps. Okay. And we take a look at some of the apps. So let's, am I in open source? Yeah. So I'll just go to look at, okay, Smart was developed by Boston's Children's Hospital. So Smart Spec came out of Boston's Children's Hospital. So that's why you see a lot of early apps from them. So you go to view, and then you can do a try app. Okay. So you select a patient. So in the background, the authentication and authorization happened, right? And that was visible on the link, okay? And then you can see very good layouts here, right? So now the beauty of this app, the Smart Spec is, for example, if your EHR does not have a particular a good UI for rendering growth charts, right? What you can do is you can actually integrate this app with your EHR, right? So that whenever somebody is wanting to look at growth chart, instead of the default EHR app, you open this growth chart app, right? So basically on the back end, a lot of things happen. And what happens, you can just go here. Where is it? So first, before we go there, so you can download this, since this is open source, you can download it, and so the source code repository is here. You can download it and look at it and experiment with it, okay? So now let's go to let's go to the documentation. Where is the launch sequence? So this is, I was talking about embedding, right? So you can use this flow to actually do an EHR launch of your app. It's like from the EHR, you launch your app, right? So there is a spec that the smart spec talks about it, how to do it. Similarly, if you have a standalone app, right, which actually just uses the data from the EHR server, there is a way to do that also, right? Integrate to your standalone app with the EHR server, right? So both ways are possible, right? So take a look at these, experiment with one of the open source apps, right? And understand the flow, right? And maybe in the next session, whenever we have, right, we actually talk about Smart on FHIR also as one of the options. So we have two suggestions already. One is working with IGs and profiles, and the second is maybe working with a Smart on FHIR app, right? So just take a look at the app gallery. Take an open source app, download it, experiment with it, and try to change the endpoint to a public server and see if it works or not, right? And if it does not, what are the issues, right? Figure out the things like that. So with that, I think I close today's call. Again, the request is please share some info, some details, some words about the FHIR India community. Let the community spread, right? With that, thank you all for joining me on this FHIR basics journey for last 5 weeks. Hopefully the learning was good for you, and hopefully you have learned a little bit more than what you learned earlier on the topic of FHIR and working with FHIR. With that, again, thank you. I stop the recording now.
Recording stopped.